What's up, my friends? Thanks for watching. We're going to evaluate the integral of 1 divided by the square root of 4 minus x squared. And it's going to be awesome because we're going to use a trigonometric substitution. And I know I want to try a trig substitution because we have a square root here and we have two terms that look like they're squares as well. So, after we evaluate the integral, I'm going to show you kind of how it looks graphically, which is really cool to see. So the first thing we're going to do is take the square root and we're going to call it something. I'm just going to call it g. And we're going to rearrange this equation to have it in the form of a squared plus b squared equals c squared, like a right triangle. And that's key. This is the key here. So the hypotenuse is the term that's kind of by itself. And then the other ones, g and x, it doesn't matter which side of the triangle you put it on. It'll work either way. But this is the trick to set it up correctly. Now, theta is going to be this angle right here. You could have it on the other one, but it's just like kind of easier to put the angle right here. And to write theta in terms of x, we're going to use sine because sine is opposite divided by the hypotenuse. So if x can only go from -2 to 2, now it can't equal those numbers, it's got to be greater than or less than, then if we plug in -2 and 2 into here and solve for theta, then our limits for theta are from -pi/2 to pi/2. Now, I know there's no limits of integration here, but we are limited in our values because we have the variable under the square root. Okay, and this makes sense. So to go be less than pi/2, if this is 0 right at the horizontal axis, then 90 degrees is pi/2. We can't have a right triangle greater than that unless we start kind of flipping over to the other side. And then -pi/2 is if we were to go the other way, we were to draw the angle the other way down to there. Okay, so that gives us an expression between theta and x. Now we're going to get one to write this square root in terms of theta. And we'll use the cosine because cosine is adjacent, which is our g, divided by the hypotenuse, which is the 2. And now here we have two expressions, one for theta and x, the other one for theta and our square root. And we're just going to rearrange things a little bit so that we can substitute it into our integrand right here. So x is equal to 2 sine theta. And if we take the derivative and rearrange, dx equals 2 cos theta d theta. And now on this side, if we rearrange, g is equal to 2 cos theta. So we're going to take these two equations and sub them into our integrand right here. The numerator, dx becomes 2 cos theta d theta. That's the numerator right here, 2 cos theta d theta. And the denominator is our square root. And our square root is g, which is 2 cos theta, which we have in the denominator here, 2 cos theta. And check this out. We have cos theta over cos theta. We have 2 over 2. Those cancel. And we now have like the world's easiest integral, the integral of d theta, which is our friend theta, plus our integration constant, c. Now, we can't leave this as our final answer. We need to substitute back into x because that's what our integral is in terms of x. So if we solve for x, here x equals 2 sine theta. So if we want to solve for theta, theta equals arc sine of x over 2. And that's it. That's literally our answer. And we're done. But check this out. If we say this integrand is in red and the arc sine is in blue, this is what it looks like for the graph. So this integrand is the derivative of the arc sine because we got to take the derivative of the arc sine to get this right here. So this part in red is our derivative. And what does the arc sine look like? Well, it looks just like this. And this makes total sense. See our function, our arc sine, as we go from increasing towards 0, the slope gets lower and lower. So the derivative gets smaller and smaller because the slope gets lower and lower. But as x increases beyond 0, the slope gets steeper and steeper and steeper. And if the slope gets steeper, then the derivative goes up and up and up. And then we have asymptotic behavior at -2 and +2. Right on. Okay, hope that was helpful. I've got tons and tons of integral problems and math problems and whatnot. Hang in there. You can survive. Cheers.